So I'm Derek, and thank you for coming to Dataflow for Beginners. So we have a lot to talk about. I will be talking about Beam YAML, doing the intro, pipeline structure, examples, lots of transform examples, advanced topics, and then Cham will be talking about job builder, intro, features, data movement jobs, data processing patterns, and working with YAML with job builder. So let's jump in. So right now, the current state of Beam and Dataflow is that we have these nice SDKs for different languages. We have Python, Golang, and Java, but it requires a lot of programming language knowledge and the whole Beam model ecosystem. We also have Dataflow templates. They're great for like single-use cases, but they require, if there's any tweaks to them, it requires a lot of knowledge about the pipeline, and it's almost like you're writing a pipeline from scratch. So the current state of what we have in Beam and Dataflow is that we have these nice Beam SDKs, which require a lot of powerful, they're very powerful, but they require a lot of skill. And then you also have the templates, which are very single use, but they don't require much skill to kick off and deploy. What we're proposing and what we want to talk to you today about is Beam YAML, which requires less, they're less powerful but less skill required, but also Job Builder, which is going to connect the templates and the Beam YAML together. So some of the goals of Beam YAML design is that it's a schema-first design. It's structured as a Beam row. We incorporated the standard IOs, the windowing, turnkey transforms, all the main Beam functionality. There's error handling per transform basis, easy syntax via the YAML, built-in transforms and IOs that can be executed via Java and Python. We also want to try to provide Google provided Dataflow templates that can run YAML pipelines. And then we also want to allow code translation for getting started with Beam. So let's talk about the Beam YAML pipeline structure and examples. So here we have a simple read from pub sub source and going to a sync of write to BigQuery. Pretty simple. But we can do better. We can add more transforms. So in this example, we have a map to fields. And we're taking the input from the read from pub sub name. We're uppercasing everything. And then we're also adding 20 to the age that's coming in from the pub sub and passing it to write to BigQuery. And we can add on many, many more transforms via Beam YAML. In this example, we're just adding on explode and et cetera, et cetera. But we don't have to be linear. We can have multi-source, multi-sync. In this example here, we have two sources. We have read from PubSub and read from Avro. And read from PubSub's sending data to the map to fields transform. And then they come back together as part of the join transform. We also provided sophisticated error handling. So in this example, say there's an error in the map to fields transform. We can easily send those errors to the write mapping errors transform, and any good data will be sent to the write to BigQuery transform. We've also built in Jinja 2 templization. We'll go in more detail, but when we're passing in threshold and table prefix, it allows the pipeline to be dynamic instead of being very static. And this is just another example, a full example of where we're reading from MySQL. We're filtering based on category of electronics. We're combining based on a group by product name. And then we're just writing the data to CSV. So we currently supply all the Beam, or all the transforms that you're used to. So we have a read from, write to, Avro, CSV, JSON, Parquet, MySQL, BigQuery, PubSub, Kafka, etc. And the whole laundry list is there in that link. And then we also supply the main areas: utility, mapping, aggregation, ML, other. So generally, there's 3 ways that you can kick off Beam YAML jobs. You can use the Dataflow template UI. You can also use the gcloud Dataflow tool. And then you can also just kick it off locally via the Python command with that YAML pipeline file. So let's talk about some basic transform examples. I won't go into too many, but I will dive into map to fields a little bit more in depth. So map to fields, you're just taking the input collection and you're outputting it to the next transform via expressions, callables, files. You're also providing, there's the filter transform where you're just using an expression callable just to filter out the data that's coming in. You can also use the explode. In this example, we just have a name A, iter 1, 2, 3. We just want to break it up into 3 different elements. Then we also have a partition transform. So we have input collection coming in, and we would just want to break it into multiple output collections based on a condition. And then we have a basic assign timestamps that we can assign to the data. So let's jump in and get deep on map to fields. So in this very basic example here, we're just taking the column 1 data that's coming in. We're going to change it over to the new column field. And then we're just going to add in hard-coded int literal, float literal, and string literal. Pretty simple. In this a little bit more bigger example, we want to save the my old num to my new num based on a lambda expression where we're just multiplying it by 2. We wanted to save the my old string to my new string, ABC, and then my old name just gets uppercased. We can also use callables. So we can use the Python language, and with that function, we take the beam row, we convert it to a dictionary, and then convert it to JSON and save it as a JSON string. There can be situations where we can't, Beam YAML cannot decode the schema. So we can easily fix that by adding an output type of string. And then this is just another example where we're doing the schema and then specifying the output types. We can also use Java. So we have this class, my function, that we're going to convert basically my old num to my new num from 123 to 246. And then we have a UDF function that uppercases my old name to my new name. We can also use SQL in the similar process where timestamp becomes timestamp. My new num is my old num plus 1, and then we're uppercasing my old name to my new name. So let's talk about aggregation transforms. So we have combined, we have the standard built-ins, sum, max, min, etc. And we can also supply custom transforms, and multiple languages are supported, such as Python and SQL. In this example here, we have a column 1, column 2, and we want to group by the column 1. So we have 2 A's, and that's the count of 2 there. There's 1 B, count of 1. And then we're just going to sum on the column 2. So A has 4 because of 1 plus 3, and B is just 2 since we only have 1. But there's a lot of flexibility with Beam YAML. We can be very explicit, or we can dwindle it down more. So instead of specifying the type, we can just specify the sum function. And we can even do it better. If we're going from column 2 to column 2, we can just specify the function as well with this sum there. And then we can also use SQL language to specify the same thing with the count and the sum and give the similar results. We can also supply the custom combine function. So in this example here, we have column 1 and column 2. And we want to group by the ID. So we have 3 ones, and then we have 1, 2. And we just want the top 2 in this example. So 1 has 3 previously, but it was, 6, 10, and 12, so we'll just keep the top 2. Pretty straightforward. Now let's talk about some advanced topics. So we'll talk about providers, inlining, Jinja, ML, and testing. So we provide the ability to provide custom transforms via providers. And we can do this via inlining, PyPy packages, Java jars, and et cetera. So in this example here, we provided a Java jar, and it's called my custom transform. And we're going to use it inside the pipeline. And there you go. Similar example of PyPy packages, my custom transform again, supplied as a provider, and we call it inside the pipeline. And there you go. Now, there can be situations where we don't want to have this huge overhead and supplying all these custom transforms. So we can use, there's 2 different ways we can do this via Python transforms. We can use PyTransform, and we can leverage the provider's framework as well. So this example here, we have the PyTransform, and we have a constructor of some transform, args of 1 foo, and kw args with a baz 3. Pretty straightforward. We can also pass in a constructor. So we have this nice class, my p transform, and we want to pass in a increment of 10. So the original column 2 was 4, 5, 6, and in this example, it easily get updated to 14, 15, 16. We can even use a callable. So we have a my transform with that beam map with a lambda expression. So we just add that increment that we just passed in of 10, and it gives the same result. Then we can also just use the Python provider. So in this example, we have a my transform that we're passing in with that similar lambda expression. And then we have a config up there inside the pipeline of 10 that we pass in. And it gets converted from 4, 5, 6 to 14, 15, 16 like before. So now let's talk about Jinja templization. So there can be situations where we don't want to use a static YAML file because it could be a variety of reasons. We got sensitive information. We have, maybe there's certain teams that want to tweak the overall pipeline, or maybe we don't want to do all this copy and pasting everywhere with the YAML blocks. So with Jinja, we can inject the variables. We can inject these sensitive information that the engineers can't see it, but during runtime, it will be populated. We can also do dynamic construction of the pipelines, so we don't have to have a static pipeline. And then we can also centrally host YAML blocks and files. So in this example here, we're passing in a Jinja variable with threshold 5. So during the run, in the filter transform, we have an age greater than 5. And this is really cool, is that instead of having a very static system where we maybe previously had a read from pub sub filter and write to staging, now via Jinja, we can pass in and use staging of true, and it will go to write to staging transform. But if we pass in false, now it dynamically goes to write to prod. We can also provide library files. So in this example, we have a provider's YAML file, and we're passing in the my custom sync transform, and we're going to put that into our pipeline and use it. Now let's talk about ML briefly. I know some people have already seen this in other presentations, but with the ML run inference transform, we want to take the input rows that we get from the previous transform, and we want to append the predictions or the inferences. So in this very basic example, we have elements of like, what is a car? Where is the Eiffel Tower located? By using the run inference with, say, for example, a model handler, a Vertex AI model handler, JSON, we get this output here with the inference, with the prompt, what is a car? And then with the inference attached to that inside the Beam row. Another ML example here is that we have some very basic data, num0 with some text, num2 with some text. And then we do some very common machine learning processing where maybe we're scaling. It's a very silly example, but we're scaling from 0 to 1. And then we're also scaling min and max of 0 to 100. And we get these results down at the bottom of a num scaled 0, 25, 62.5, and 100. Now let's talk about testing. So it's great that we have all these YAML pipelines and everything, but how do you test this? Do you want to comment out everything or what? So what we provide is this testing section down here in the bottom here. And in that testing section, you can write like, what kind of output do you expect? Or what kind of input do you expect? So in this example, we have a read from GCS. We better receive nothing can come of nothing coming out from that transform. And similarly, from the write to GCS, we better be getting output nothing to, can one, come one, and of one coming in to this transform here. And we can easily execute this locally by hitting this command with this test flag. And here's a couple of links about Beam YAML. We have Beam YAML docs. We have, if you want to create a Beam Java transform with Beam YAML, we have a Beam YAML blog. We have lots of examples of Beam YAML. And then if you want to get started with Beam YAML, we have that link there as well. Thank you. And now Cham will talk about Job Builder.
All right, so I'll be talking about Dataflow Job Builder and how it relates to Beam YAML. So what is Dataflow Job Builder? Job Builder is a visual UI for building and running your Dataflow pipelines. Job Builder is completely backed by Beam YAML, so everything Tarek mentioned will also be relevant for Job Builder. Job Builder also allows you to save your pipelines in GCS as Beam YAML files. So this allows you to do things like develop your pipeline, save it in a GCS bucket, and share the bucket with rest of the team members in your organization, and then they can run your pipelines, right? So you can develop pipelines in a collaborative way. Also, Job Builder comes with a set of pipelines that are predefined for you that you can just load and run. These are called blueprints. So how do you get to Job Builder? So if you go to Dataflow Cloud Console UI, just click this button, Create Job from Builder. And that will get you to this Job Builder UI. There, you can select the type of your pipeline, whether it's batch or streaming, and start developing your pipeline. All right, so why should you use Job Builder? One main reason is that with Job Builder, there's no need to download, install, or maintain a Beam SDK. That's maintained for you. Also, visual editing of a pipeline can be much more useful in some scenarios for some engineers and could be very quick than developing a pipeline programmatically using a Beam SDK. Also, Job Builder gives you enough flexibility to customize your transforms and configure them using the UI itself. And this should be enough for many of your pipelines. Also, Job Builder is not just for developing pipelines. You can also use the same UI to validate your pipelines as well as to run your Dataflow pipelines from the UI. All right, so how do you go about developing a new pipeline using Job Builder? Well, you would typically start by defining some sources, right? So this is where your data comes into your pipeline. You would select one or a few of these sources, and this lists some of the sources available via Job Builder. And then you would go about configuring your source, right? So for example, if you select CSV from cloud storage source, you would have to give the file path to your CSV files in cloud storage. And you can just click Browse and select your file path. And there could be other optional configurations, like for CSV, there's a delimiter character, which defaults to comma. You can change it if needed. And some sources might give you additional features. For example, if you select BigQuery table source, you could go and select the exact fields you read from the table, and that will allow you to read more efficiently from that source. So after defining your sources, you would go and add your transforms that has your main business logic. And for there, go and start adding, under transforms, start adding new transforms to your pipeline. And this lists some of the common transforms available for you via Job Builder. And finally, you would add your sinks. This is what you use to write your data back to storage systems. And this lists some of the sinks available via Job Builder. All right, so let's talk about some of the ease of use features that we've made available via Job Builder. So one of the things that I already mentioned was blueprints. Blueprints include some of the widely used pipelines that are already built for you, that you can just load them to UI and run them. But this is more useful. It's not just load and run. You can load, customize, and run. So you can just load the blueprint. Within the UI, you can add your own transforms. You can delete existing, and then run them. Right? And once you modify a pipeline, you can, again, save that in GCS. So you don't have to go and start from the initial blueprint again, and you can save in GCS and load that back directly. And this is how you get to blueprints. Click the Load Blueprints button, and this shows the blueprints available today for you, but we will be adding, we're hoping to add many more of these in the future. So if you have feedback about any missing blueprints that we should add, please click that link, send feedback, and send feedback to us. We'll read that and add many more of them in the future. All right, so after you define your pipeline, you should typically validate it, and you can validate it from the UI. Just click the Validate button there. This is like a syntax level validation, so it does things like make sure your transforms are configured correctly, make sure that input and output types map, etc. But it's always good to do this before running a pipeline. Also, Job Builder comes with a dynamic job graph. So when you add transforms to a pipeline, it usually you see big boxes that you configure. It's kind of hard to visualize your pipeline using these boxes. So what you do is in the right side, you would see a job graph that we dynamically update for you. So as you configure your pipeline, this job graph will also update dynamically, and you can easily visualize what your steps are and how they map to each other. Some of the sources have additional features. For example, you can preview some of your source data. If this feature is available for the source, you will see this button, Preview Source Data. Click it, and it'll show some of the data available in your source within the UI, and that might help you to make sure that this is the correct data set I want to read. All right, so let's talk about how you can use Job Builder to customize your data movement jobs. So if you're familiar with Dataflow templates, either traditional templates or flex templates, these are great for jobs that move data from, say, source A to sink B, right? And there are a number of these. A lot of people use this. But one downside is that your pipeline is fixed, right? And if you want to customize it some way, that's usually a little bit high effort. This requires defining a new template, Probably requires defining a new container to handle dependencies for these templates, etc. And also requires configuring this template. Now, many of your jobs are not just read and write. It requires some transformation, right? So for ETL type jobs, you need to add some steps in the middle that customizes your data. And some of these steps can be like your own, right? It might be your own transforms, or it might be your own configuration that you need to add. So this kind of cases, it's kind of high effort to use traditional templates. So Job Builder makes this much more easier. As I mentioned, it's much easier to load blueprints and customize them. It's also easier to define new pipelines, right? If you have new pipelines, it's easier to define them as well. It's easier to define new transforms and add existing transforms. And it includes a number of transforms that are very useful for ETL type jobs, like Derek mentioned some of them: mapping, filtering, combining, etc. They are readily available for you to use. So let's go through how you can configure some of these transforms via Job Builder. All right. So first one you might need is the filter transform. To use this, just click the drop-down box for transforms and select filter. And then this allows you to filter out some of the elements from your incoming P collections, right? So this is the functionality. And you can give your filter expression in few ways. For example, this can be a Python expression, or it can be a callable, etc. And you use the fields in your incoming P collection to define what your predicate or expression is for filtering data. So here, you have a field called myField in the incoming P collection. You can equate it to some string if it is a string, or you can, if it's a number, you can, do some customization. Yeah, so that's how you would use filter. Another transform that you might typically use is map fields. So this basically defines new fields for the outgoing P collection compared to the incoming P collection, right? You have the option of preserving existing fields or not. So if you want to carry forward all the fields from the incoming P collection, you can just click that button, and your new fields will just add to them. So you'll be adding to the existing set of fields. Or if you don't click that button, all the existing fields will not appear in the following P collection. It'll just include the new fields that you add. So here's an example how you define a new field. So I'm adding a field called year, and I am using a callable to define what this field should be. So I have an incoming raw object that has my data, which has a field called year in it. And I define a function that returns what I want. In this case, it converts this to the Roman format. And that will be your outgoing field. We also have features for doing things like defining new Python dependencies within the UI. So you can add them and use them right there. All right, so another common thing you might do is joining. There are several transforms available for this. One common one is SQL transform. So click join and click SQL transform. Sorry, join is your name of the transform, and click SQL transform. And once you do this, you can use this drop-down input steps for the transform to select the incoming P collections, incoming data sets that you want to join, right? So it will basically list the other steps you defined in your pipeline, and you select 2 or more of these to join. Yeah, so in this case, we joined using a SQL expression. We selected 2 incoming steps: taxi ride and zone lookup, taxi ride data and zone lookup data. And these will be represented as input 0 and input 1 in your SQL. And we join using fields PU location ID and location ID. Now, another common thing you might need to do is handling errors, right? So some of the transforms allow you to output your error records into a new P collection. If this functionality is available, you will see this button called Handle Errors. Click that. What this will result in is this transform producing two different P collections that you can handle separately. One will produce your main output, that your normal data, and the second P collection will include your error data. All right, and then you should typically define two downstream steps, one to handle your normal data, and second one to handle your error data. So what I do here is that I define two sinks. The first sink, write output to GCS, handles my normal output. So this input here is the format output step. And the second step handles my error output. And the input step is the same, but it's called format output errors because that's the error output of the format output step, right? So if you just click this drop down, you can either select the normal output or the error output, and you can handle them accordingly. And the first one, these are also two different sync types. First one is writing text files to cloud storage, and the second one is writing CSV files to cloud storage. All right, so let's talk about how you manipulate YAML within your Job Builder UI, right? So as I mentioned, Job Builder is completely backed by Beam YAML. So this allows you to also directly manipulate, update pipelines using the YAML format. If you want to save your pipelines using YAML format, there's a button for that. Just click that, which brings up a panel like this, which allows you to save your pipeline in a GCS bucket. And as I mentioned, you can share this with your team and collaboratively develop your pipelines. And also loading them back into the UI is also pretty straightforward. Just, there's another panel, click that, click Browse, select your files, and it'll load the pipeline into the UI, and you can modify it there. Job Builder also comes with a YAML editor. So typically what I explained so far is the builder form in the UI. But if you click YAML editor, it'll actually show you a YAML pipeline. And this editor comes with some nice features. It does some validation for you. It does some highlighting for you. So that can be a good way to, if you're already familiar with Beam YAML, you might like this UI as just the editor for your YAML pipelines. And you can edit it there. And you can go back to builder form, et cetera, and then just directly work with YAML pipelines. Also, I think Derek mentioned providers. This is what allows you to load your customized transforms into Job Builder, which is a YAML feature. So if you already have a YAML provider, so if you want to use custom transforms that you already built that you want to use in Job Builder, just add your provider file to your GCS, and just select it here, and these transforms available in the provider will be available to your Job Builder pipeline. So in this case, I selected this provider, and we support YAML transforms, Python transforms, and Java transforms here. So depending on that, you will see the transforms that we will load in the top. So here it loaded two transforms, range and power. And then all you have to do is click plus, and these transforms will appear in your Job Builder UI, and then you can configure them and add them to your pipeline. All right, so that's what we wanted to cover as a basis for developing Dataflow pipelines.